Hello, my name is Eric Barnes, and this is my assignment 1. First off, you can choose. We're going to run through the code. You can choose the search method by algorithm, so I'm going to run through all these options. Breadth first search, easy, medium, hard. Depth first search, easy. I'm going to skip medium. It takes a little longer. Hard. Uniform cost search, easy, medium, hard. Best first search, medium, hard. A star search, easy, medium, hard. And lastly, A star 2 search, easy, medium, and hard. Here's the depth first search medium puzzle. It takes about 25 seconds to solve. To model a state, I chose to create a puzzle class. A puzzle class has a string called puzzle, which is the current state of the puzzle in a string form, an array list of puzzles called successors. This is all the valid moves you can make from the current state. A pointer to the parent node where the state came from, cost, the cost of the move just made, total cost, the cost it takes to get to this current state, including all moves, description, up, left, right, down of the move just made, depth in the tree, estimated value would be a heuristic, and index of the zero in the string. For my successor method, we're going to be generating an array list of puzzles of all valid states you can move from puzzle P. I get the puzzle, and I get the index of the 0 in the string. Then I attempt to move right. If it's a valid move, then I create a new puzzle with all in the tree and add it to the successor list. I try to do this for left, right, up, and down. If they fail, they are not added to the successor list. At the end of this function, we'll have a list of all valid moves from the current puzzle. Each of these up, down, left, right moves check the current index of I and accordingly swap if the index is valid for the move. For my main loop, I chose to implement the search methods using the strategy design pattern. I have a puzzle searcher interface that has a generic search method. Each algorithm then implements the search method. So then I can say based on the index they choose, I'll create a new BFS object or a new DFS object. And this allows me to then generically call search puzzle, and whatever search method I have chosen earlier will be used and utilized. For all search methods, I chose to use a hash set, and for each value that is popped off the queue or the stack, it is then added to the visited hash set. So then when I'm looking at successors, I can check in a constant lookup time if that visited already contains the puzzle generated from successors. Another way to look for duplicates besides my visited hash set is checking if the current successor already exists on the queue. For BFS, I used a linked hash map, so I have a constant lookup time. But for DFS, I used a stack, and that only provides a linear lookup time. I also used priority queues throughout my search methods, and that only supports a linear lookup time. Here you can see the contains method loops through all the puzzles and checks if the estimates are the same. Across all the search methods, there are various ways to push and pop values from the queues and stack. For BFS, we use a generic first in, first out method. You push new states onto the queue in the order in which they were received from the successor. This spans out and searches the tree in a breadth format. For DFS, we use a generic queue that has a first in, last out format of popping new nodes onto the stack. For the other search methods, I used a priority queue. This is different from a queue. It doesn't operate on a first in, first out basis. Instead, when adding new states to the queue, it inserts the value in a sorted form based on comparing the estimates of the two nodes as it traverses the queue. This creates a sorted list and sorted queue and gives priority to those states which have cheaper estimates or costs. For each search method, this estimate differs. For A star 2, it's the sum of every tile's Manhattan distance plus the total cost to the state. For best first search, it's the total misplaced tiles for this state. For A star, it's the misplaced tiles plus the total cost to this state. And for UCS, it only utilizes the total cost to the state. And that's it. Thank you for watching.